AFP presents the MDVG series. Here's a brief description of how a 6-port sample injection valve works. Carrier gas is flowing into the separation column while the sample loop volume is connected to the source of sample. This is the sampling position normally achieved while the valve is in the off position. When the valve is set in the on position, the sample loop volume is placed into the carrier circuit. The sample is then transported to the separation column, and individual impurities peaks are fed to the detector for quantification. The valve is turned back off to start another cycle. Here's the new generation of diaphragm valve oriented for gas chromatography, the MDVG series. With all its patented features and incomparable performance, this valve series will boost your instrument performance and reduce your maintenance cost and time. Let's start with the valve body. We have 4 screws to hold the valve head to the cylinder. This creates an equal sealing of the whole diaphragm area. We also have spring washers that will compensate for heat variation. When starting at ambient temperature and ramping up to 250 degrees Celsius, there will be a metal expansion and stress, especially around the diaphragm area. Since everything is tightened by 4 screws, we added 2 spring washers per mounting screw to absorb this excess tension on the diaphragm by compressing itself to unload the diaphragm. This is also good when coming back to room temperature. These spring washers will return to their original height to conserve the proper load to the diaphragm. We have 4 screws to hold the bottom cap of the valve that will hold the actuation. The small one in the middle is used to adjust the normally closed piston and not to hold the actuation in place. By introducing pressurized gas at 60 to 65 psi in the actuation port, the pressure will build up and make the 2 pistons move. But the difference we have is that since we can adjust independently the normally closed screw, we are able to perform break before make actuation. By adjusting this normally closed screw, we are able to adjust the deadband during the actuation to prevent mixing upon actuation. Once the adjustment is done per the application request, we lock this screw in place with a set screw with a soft tip to preserve the threads of the screw. What is mixing? Flow mixing is a phenomenon that occurs in a GC diaphragm valve upon actuation. For a short period of time, all the ports of the valve communicate. For example, all ports are open at the same time. This means that any high-pressure stream can flow back in any lower-pressure port or stream. With our unique adjustable screw, we can adjust it to avoid such mixing. Here's how our valve actuation sequence works. First of all, our valve is in the off state, which means normally closed plungers are up, closing the flow, and normally open plungers are down, letting the flow pass through these sections of the valve. The valve is then actuated with 65 psi of inert gas. When the internal pressure reaches up to around 30 psi, the normally opened piston goes up to close these sections. Note that the normally closed piston is still in the closed position. Depending on the tuning that has been done, we can keep these 2 pistons closed during 5 to 15 psi. We call that the deadband. All plungers are closed. Now that we have reached 45 psi, the normally closed piston will start increasing the compression of the Belleville washer stack and at the same time allow gas to flow in these sections. When reaching the final actuation pressure of 65 psi, the normally closed piston is fully open and the actuation cycle is done. Our valve is based around one concept: self-aligned plungers and self-balancing of the force transferred to the tip of the plunger thanks to the bearing ball. Let's start at the bottom. There is the normally closed screw pushing on a ball to preset the loading strength of the Belleville washer stack. This ball is making sure that only the vertical force is transferred to the piston. The same concept has been applied to the push plate plunger to make sure everything is aligned. Now let's go to the most important point. The plungers. This new plunger concept is split in two in order to be self-aligned. This design allows the lift force to be transferred to the top plunger through a tangential point on the ball. Plungers are also attached to the pistons, so they can be used in any orientation, even in moving vehicles. There is no rotary force from the piston transferred to the plunger, resulting in a self-aligned plunger. The base plunger is precisely machined in stainless steel, and there is no friction with the valve cylinder. The upper plunger is also precisely machined out of a low-friction alloy to avoid wearing and ensure a long lifetime of the valve. Since the force is applied to the total surface area of the plunger, we are getting an equal sealing force on the diaphragm. Our diaphragm is made of the highest quality polyamide. It can also be coated on one or two sides with different types of materials, such as Teflon, gold, nickel, etc. This is really customizable to your specific application. Our diaphragm is designed with 3 dowel pins with a special angular position to make sure it is put in the right position when doing the replacement. Our valve is designed with relief pins to ease the process of diaphragm replacement. You only need to actuate the valve to bring down the normally closed piston, and then you can put in place the 2 relief pins and then release the actuation pressure. This will maintain the normally closed plunger down, and since the normally open piston is already down too, this makes sure that the diaphragm will be well seated in its groove to ensure it gets the same flow rate as per the factory assembly. These relief pins are also a great help for long-term storage to prevent the stress on the diaphragm when not in use for a long period of time. The last but not least feature of this valve is our unique and patented purge design. Let's see how it works. We have on the left side of the valve the purge inlet, where we usually connect the purge carrier gas of the system with only 5 cc's per minute at atmospheric pressure. We have different channels for the purge flow for different reasons, and the purge gas can go out of the valve by the purge outlet and vent in a safe area. Here's the purge flow path. First, there is the red dotted line here showing the outboard purge flow path. The gas will go up into the valve head groove to prevent outboard contamination of the process groove by the atmosphere from the outside diameter of the valve. Then this gas finds its way out by the purge outlet. There is the blue dotted line that will do the same job as the red one, but now to prevent contamination from the valve head mounting hole. The upper section of the actuation is also purged to ensure there is no accumulation of sample gas and to create an inert environment. Then, the last channel, one of the most important paths of the system, is purging the back side of the diaphragm. For the most demanding application, for example high-purity helium analysis with a plasma emission, or PDHID detector, and mass spec, permeation is an issue in most cases. With the help of this purge groove, we are creating an inert atmosphere underneath the diaphragm with the same carrier gas as the application, in this case helium. This has the effect of accelerating the startup time of an instrument while also increasing its level of detection. This last purge flow path gives us also the opportunity to operate the valve in a vacuum application like GCMS with the diaphragm valve, which was not achievable before. By plugging the purge inlet of the valve and by applying a vacuum source in the purge outlet, we are creating equilibrium of pressure on each side of the diaphragm, so the valve performs as well as in atmospheric application. Wondering how to bring more intelligence to your instrument? The answer is easy. Use the benefit of our purge system to monitor the quality of the purge gas coming from the purge vent and compare it with the carrier-generated signal. If there is too much of a difference between these two signals, it means that the valve system is leaking. This feature gives an early warning of valve wearing. This also prevents unscheduled system shutdowns. To know more about this feature, please read our Application Note 4 available on our website. Now that you've seen this product with all its features and benefits, you can easily understand why our product gives more performance to your demanding application. At AFP, we are not just a part seller, but a solution provider. Please share with us your most challenging application, and we will find a solution based on our experience and product portfolio. Find more products information on our website at www.afproducts.ca.